I will be going over forced air guidelines class, which is basically a heat loss class, and basic duct design class for the guys that take it, for your guys as contractors who take the class, or if you guys want to take the class. I'll see if I can figure out the remote control thing. Okay, so my name's Jason Rockson. I've been in the trade since '93. I own Mercury Refrigeration. I live in Duncan, or just outside of Duncan. I technically live in Shawnigan Lake. I'm a refrigeration and gas journeyman. I've been volunteer at TechN teaching this class and the class that Terry just went over for 15 years. I'm on the vent committee, the same as Terry, and then, like I said, I'm the instructor. So if you have questions that come up after this that you need the other side that Terry just went over, I can answer those questions too, so I should be able to. So basically, I had a complaint already in the room about the sheets because I wasn't told you guys were getting a sheet with a picture this big on it. Because you can't even read this on the sheet. So I don't know how much I would have changed it. I probably would have said to make it full page. I thought you guys were getting full page pieces of paper. So I'll try to go over it, and then I got the base file, the base PDFs in my open here as well, so I can actually pull them off the PowerPoint and make them actual a lot clearer, so we can see what's going on. So basically, part 9 we'll discuss is the ventilation portion, which is what Terry already went over. So we're going to discuss some of the stuff in part 6, which is the heating and air conditioning side. Basically, ducts in unconditioned space. The parts of this, it was always supposed to be there. Now there's actual rules about how much, which you guys would have done if you guys have sat in the 936 class for how much you're supposed to do. You need to insulate it to the R value of the wall now. All returns, and we can't run up outside walls anymore because we need to keep the R value of the wall, all those kind of things. I'm not going to go over too much of the energy efficiency stuff. Returns and supply openings, they have to have a grill if they're below pretty much 2 meters, which is 6 feet. Same issues as electrical and protecting stuff. You don't want somebody to fall in or do whatever else. So unless it's on the ceiling, it has to have some grills on it. Fresh air vents are to be installed where there's no contaminants. So don't sit it where you park your diesel truck every morning, because if you know, especially if you know that's where it's going to be, otherwise all you're going to do is just puke all that stuff into your house. Have some thought process, and hopefully the installing contractor doesn't put it beside the one parking spot that's in the whole house. So try to put it somewhere where it's actually going to get fresh air, because all houses have fresh air now, which is what Terry went over already. So not like before. All duct joints have to be sealed now. Warm air supplies should be installed in every room that's adjacent to unheated space, which means the walk-in closet is supposed to have a vent in it or have heat in it. So, or the bathrooms and everything else. So we need to, and then one vent for every 40 square meters. For all the guys that are metric, it's about just over 400 square feet. So if you're doing a unfinished basement or whatever else, if it's 800 square feet, you'll need a couple of vents at least. Return air system should be designed to handle the entire CFM. The main reason why I put this in here for you guys is when you guys look at it and they run an 8x20 supply air duct to do the whole house, and then the return air duct is an 8x10 duct, there's a problem there. It's not going to get the same amount. Realistically, they should be close to the same size. So, or bigger on the return side even. So just kind of when you guys are looking at things, most of the way I've kind of set this stuff up is just so you guys are informed. So when you guys are going on job sites and even talking to the guys that are doing your work and everything else like that, you can notice some things that just don't seem right that maybe you didn't know about before. Because I'm not going to teach you how to do a heat loss, like full heat loss and stuff. We just don't have the time for that. It's a 3-day class for what we're doing. Terry had the 1-day class condensed to an hour. I have a 3-day class condensed into an hour or so. What do you got? One return air system, vertical vents. So what they're saying for the vertical return airs is you can't use the same stud cavity on the lower floor and then go straight up into that same one and go up to the upper floor because of fire rating. So you have to make sure you stagger them in different joist spaces so that they have to kind of zigzag back and forth. And if there's a fire or smoke coming through. And there needs to be at least one return air per floor, which would include crawl space if it was heated. So you want to make sure you're turning the air on every floor. So if you're putting, usually, because I'm one of the few installers that teach the class, so usually the plan would be is if I'm putting 500 CFM on a floor, I try to return 500 CFM from that floor. It doesn't always work that way because sometimes it's impossible to get a duct to do it, but at least get a return IR on every floor so you're turning some of it. And a lot of new houses have open floor plans, and open railings and stuff like that, which means the air will pass from floor to floor, so it's not going to be as much of an issue. And then provisions must be made for all return air from all rooms, which would either be a grill in that room or to make sure the doors are undercut. I've been going to a lot of houses lately with super plush carpet, and it's great. They were undercut when the floor wasn't in, and then the carpet and the pad and everything else going in, and now the thing's like dragging on it. Like, you got to have room for the air to go somewhere, otherwise you're just going to pressurize the room, and then it's not going to get any more heat or air conditioning if they have both. And then all supplies should be dampered of some kind. So in the old days, you always had the metal dampers in the unfinished basement. Most of the time now, the grills have the little slide or the roll or whatever it is if you put basic ones in, or if you're putting more expensive ones in, you have the screwdriver where you can do the flaps inside. So those are basically the kind of code stuff that has to do with us. That's like seriously condensed from what it is in the in the code book, but no questions so far?
Yeah, one for
Yes.
you. As a tradesman, what are the biggest single things that you see when you lose a contract to someone less qualified? What are the biggest shortcuts that are done to hurt the final system?
Well, probably heat pump wise, because I do a lot of heat pumps. We do a bunch of gas, but I don't do tons of gas. Is somebody walking in and putting a heat pump in that'll only cover 50%, and then they're running on electric the rest of the time, which is kind of, they might as well just put an electric furnace in the house. So that's probably where I lose a lot of jobs, because a 5-ton heat pump costs more than a 3-ton heat pump, basically. So in a couple ways, I have to put bigger duct in than the 3-ton guy, and the heat pump itself and the air handler costs more money. So I have that, and I'll be going over it. It's one of the things I was going to go over anyway, so just so you guys can understand the reasons why things happen. But I'll go over it a little bit down the road when we start, because I have one of the slides I was going to go over was how to decide which heat pump to pick. So just so you guys kind of have an idea why guys are walking up to a whatever size house and deciding things. So basically, I just have this in here. I took it out of the thing. This is one of those slides you guys cannot read. At like no hope you're ever reading it on that piece of paper you have sitting in front of you. But I just wanted, this is just more for me to kind of make sure you guys have the information, like so I can go over it and not forget anything. So the heat loss is, we're designing to 72 degrees Fahrenheit. So if your customer wants their house at 80 degrees, they're going to probably need a bigger heating system than somebody who would want a standard kind of 70 degree house, or 72 degree house. You have that little old lady that you know is going to want her house hot. You don't want to size her or get the guy to size the house to 50,000 BTUs and then put a 50,000 BTU furnace in, because she might not get 80 degrees when it's really cold outside. I know 80 is extreme, but we all have those customers that want their house a little warmer than everybody else, or on the opposite thing, a little cooler than everybody else on the air conditioning side. So make sure you're covering off of the standard, which is 72 degrees. And then 75 for the air conditioning side is what we size to, what TECA teaches to size to. Other guys will do other heat losses that may use a different number, but you need to kind of know what that number is. So if they're only tempering their air to 75 or 78, and you know that customer's going to want their house 69 degrees and they have lots of windows, it's not going to be the same size as their neighbor who you just put in that's going to keep it 5 degrees warmer. They're going to want a bigger unit in that house. So heat transfer, we won't go over that too much. I don't want to have too much of a science lesson here. It's just a matter of trying to make sure you guys get what you need out of today, because you guys are here to try to get what you can to be a better builder moving forward and understanding what the customers need to have installed. So outdoor design temperature, which I'll go over when I show you the sheet, but I don't know. You guys are all from the Lower Mainland, or are there guys from the interior and like farther away? There you go. See, so so the same house built in Prince George compared to the same house built in whatever, Richmond, is not going to have the same furnace in it. So, and I hope you guys kind of understand that. If you guys aren't building houses in both places, you're not experiencing the difference between both anyways. But just make sure that you know what's going on and we're kind of covering things. So basically the way TECA teaches the class is we do a base heat loss, and then we multiply it by what we call a regional temperature adjustment. So what it means is when we teach the class, no matter where we teach the class, that house will have the same base heat loss, and then we're multiplying it by a factor based on where you're going to build the house. So if you were building houses in multiple places and you're building the same house in multiple places, the heat loss would be the same. You just have to do the multiplication at the end to adapt it to make sure that it would be enough one way or the higher or lower based on where we were building the house. So it makes it very universal and very easy for a lot of contractors to understand. Well, like it or not, we're trades guys. I don't know. We're not all that smart. So the math is complicated for people. And then the heat gain, I'll leave alone for right now. There we go. There. That's fine. So go to the next one. Okay, so on the heat gain side, there's two different kinds of loads, and it would be different for you guys because you're from around different kinds of province. In the Lower Mainland, we're really dealing with sensible loads mostly. We're not dealing with a huge humidity issue, whereas you guys in other parts of the province would be dealing with more humidity or dryness or things like that. So we need to take that into account. So if you're in a humid environment, we want to make sure that we're getting rid of the humidity as well as lowering the temperature or maintaining the temperature. So we got to be careful of those things. So when we're sizing the equipment, make sure the guys are taking that into account. And then the only thing that TECA does as far as allowing for influence when we do the heat gain is we add for a kitchen and the laundry, and then we don't add for anything else. So what that's saying is when we do a heat loss, we don't count sun. So at the end of the day, it's a bonus. It means you're not going to run as much because we don't know it's going to be sunny. Maybe the coldest day of the year is going to be cloudy and you need the heat. The other thing is we don't count people in the heat loss. So because people give off, we don't count the appliances in the heat loss. We don't count computers in the heat loss. We don't count your TV, your big monster TV in the heat loss that's putting off heat, all those other things. That's just all things that will add into the house. If you have a situation where you're adding a lot of stuff, then you can take it into consideration. But when you sell the house and the new person moves in and they don't have all those things, then you're still going to want the same size furnace or system in the house to make sure it'll maintain it without those options. It just means they won't run as much. Yeah.
What about on the other side of the fence where you're doing that?
I was going to get there, but yes, it's all good. But when you're doing the cooling side and you have that big theater room and everything else like that, this is one of those situations where you're going to want to make sure, is that the only room you're going to need it in? If it is, then maybe you want to put a separate system in that room, like a ductless or whatever for those guys that have done that kind of stuff, to control just that room. You don't want to be getting into a situation where you have that media room, or you have one house right here, and then on the other side of the street that doesn't have the view, you took all the window or half the windows out, but the house with the view now will need a lot more air conditioning, especially if they don't want to put blinds on, because, I don't know, people pay that much for a lot. They're not blocking the view with the blinds to block the sun from coming in. So spend some money on the windows, make sure there's not as much UV and as much heat coming in, but basically you're going to be combating and sizing the air conditioning to combat those windows. And I'm going to go over some numbers with you in a little bit for the heat gain and the heat loss so you can kind of see the differences for some of the things. But it'll make a big difference. The biggest heat loss you have is your windows. The biggest heat gain you have is your windows, depending on which side of the house they're on and whether they hit the sun or not. So just remind yourself of that when you're kind of looking at it and dealing with it and stuff like that. So that's good enough for that one. I think I'll just kind of go through this and then I'll go back to the PowerPoint. So basically, those that have taken the TECA Quality First Class, we teach them how to do a room-by-room heat loss method. So it means that they're actually sizing each individual room so they can make sure there's enough air based on the equipment they're putting in to make sure there's enough heat going in that room. With some factors in there, which I'll show you the sheet. Other people will do things a little differently. They'll use rule of thumb. They'll use stand off so many paces back from the house and hold how many fingers does it cover and tell you how big the furnace or how big the heat pump has to be and stuff like that. I'll tell you from experience, it doesn't work. So you want somebody, and when I teach the class, people don't believe this. I do a heat loss on every house I quote. Do I do a room by room heat loss? No, but I do a heat loss, which I'm going to show you guys how to do a quick heat loss. So you guys could do a quick heat loss on a new house especially and get an idea when the guy comes in and says he's going to put a 50,000 BTU furnace in and you kind of did the quick one and it showed you to be 55. Well, yeah, whatever, it's probably close enough because the quick one isn't as accurate. But if you come in at 100, then there might be a problem, right? Or maybe there's time for a discussion to kind of say, are you sure? Or something, or even the other way where he said 100 and you do it at 50. Yeah.
If you do a heat loss, in your experience, how close do you come to what you ultimately know you need?
The way I do the heat loss, it's under 10% different.
Wow.
From the room by room. But I've been doing this a long time. So I know my experience tells me things when I put the information in. Because it's no different than anything else. Computers aren't usually the mistake. it's usually, if you put garbage into a computer, garbage is going to come back out to the computer. So you got to make sure that you put the right information into the sheets if you're using, whatever, however you're doing it, whether you're doing it longhand or using a computer program to do it. So did you have a question? No. Okay, so I'm going to leave the room by room, leave that alone, heat loss summer sheets. Okay, so I'll go over that in a sec. But here, let me go back to the PowerPoint now. I just want to do that because that was some of those things that was a little bit blurry on the other sheets, like those ones. So I'll go back to that one in a sec. Okay, so yeah, that one's still blurry. This isn't. So this is what we work off of for to do the heat losses. So basically what this form is telling you guys is if we go look at what an R20 wall is, which is like an A4 wall, which is about, I don't know, 4 lines down, and it says that it says new construction, it says a number 3. So what that means is for every square foot of wall you guys have exposed outside, you're losing 3 BTUs per square foot per degree Fahrenheit. So if you had to do the math and you measure all your outside walls, forget about windows at this point, and you multiply it by 3, it'll tell you what your heat loss is for all those exterior walls. Easy math. Like we can put it in a complicated sheet and do this and do that. But basically if you do that, then it'll tell you what your heat loss is for the walls.
Excluding windows.
Yeah, that's just for the walls. That's I'll get to the windows and all. But basically, if you have a 100 square foot wall, you'll have 300 BTUs lost on that wall. There's still some other things we have to do to it in a sec, which I'll go over. You do, that's what I was going to say. So if you had a 100 square foot wall and you had a 20 square foot window, it's really only 80 square foot wall and a 20 square foot window. So those are where kind of things start getting a little more complicated.
It's not the basement, just outside.
Outside above grade walls, yes. So below grade walls have a different factor. It's actually depends on what your insulation value is, which has been changing now, and you guys are pressured to do a little bit more things with the new energy code and stuff like that for below grade walls and ceiling and stuff. So, but pick it and make sure you get as close as you can to the right factor, and you'll get a more accurate number. But I've also found that sometimes when you do these things, depending on the builder and how tight, no different than Terry said for running a big exhaust fan, some houses are built better than others. It's no different for doing this. A good insulator and a bad insulator make a huge difference. So, but go through below grade windows. Then we have ceilings the same way. You do the same math. If you have a skylight, take it out of the square footage. But on R40, the sheet doesn't have more than R40, but so you're multiplying your square footage by 1.4. It'll give you what your heat loss of the ceiling is. So the way I always remind it, and I have apprentices that I make do this so they understand what we're doing. I just make them sit in the office for a while. Is the thing to remember is anything exposed outside, you have to remember ceilings, walls. If you have floors that are exposed, like a carport or an overhang or something like that, make sure you're including those things. And then we still have loss through the floor because the ground, even in a basement, is 50 degrees Fahrenheit. So we want to make sure that you're still going to have heat loss. It won't be anywhere near what the heat loss would be, especially for the guys from Prince George on the walls, but you're still going to lose heat because you're trying to maintain a 72 degree temperature.
The ceiling was exactly the same as the wall.
It's just a different factor because of the R value is a little bit better.
So how many BTU was per square?
It's 1.4. But if you had R20 in the attic, like you guys were doing a reno and you wanted to confirm, R20 is still 3. It doesn't matter where it is. The thing with heat is because we don't take the sun into consideration, we don't care whether it's on the east wall, the west wall, the north wall, or the south wall. Once we get to the air conditioning side, then it's going to matter because it's going to matter where the sun's coming because the north side won't get sun and the south side will. But when we're doing the heating side, we don't care. It's not what our purpose would be to do the loss. And you guys, percentage-wise, I don't know what you guys percentage put air conditioning or no air conditioning in your houses. But so go down, and then we get to the windows, and the windows are the same. So then we start looking at what the Windows value is, and then going from this, the big one for me, because we do a lot of houses that are doing renos, is trying to talk people in, even though it hurts me, to put new windows in before they pay me. Because when you have single pane windows, like, I don't know, Terry's house has windows, single pane windows, but in an old house in Victoria, and you're trying to get somebody to put in, they phone in to put a heat pump or a gas furnace in their house, and you're going, well, I'm going to have to put a 100,000 BTU furnace in your house, but if you change your window, we only have to put a 40,000 in. It's a big chunk if they go put new windows in their house. And sometimes they're able to to cover some of the costs because there still is a few grants floating around for old houses. But you guys, if you're doing new houses or renos, the reno will be adding new code rated windows. So you shouldn't have too many changes from what the thing is. But basically, like a low E argon window in a wood or vinyl, which is probably the most popular, in double pane is 19 BTUs per square foot per degree Fahrenheit. So that gives you a thing, whereas if we go to a single pane window is 62. So this is where the renovation side is kind of, it pushes to get them to try to change the windows. And then they lower their cost to run the house and everything else, so it makes sense. Floors, insulated floors, then we have basement floor and crawl space floor. A basement floor would be a floor that's below grade more than a few feet, and a crawl space floor would be about 3 feet below grade. So, because the reason why it's less is you'll have less influence of outside air if it's 8 feet below grade than you would if it was only 3 feet or 2 feet. And then slab on grade is a whole nother math calculation, which is gross, so hopefully you guys aren't building too many slab on grade houses. They lose heat like crazy. But the new energy code should help that a little bit because they're making you guys put insulation on them and stuff now that you didn't have to before. And then the one thing that we have to add in, which is where we start to kind of get into the realm of whether you have an R2000 house or whether you have a standard build house, and I don't know, my experience is a good builder without getting certification is really building close to what, outside of some of the ventilation requirements and some of the weird material requirements, they're building close to the tightness of an R2000 house anyways. Now, then what, not whatever, maybe not in 2002, but it's 2017. Things have changed a little bit since then. So what we do is we have to count what infiltration is, so how much the house leaks. So we have a few factors that we look at. We look at whether it's a new construction or a tight house, and then the other things we have is whether it's an exposed house, so sitting on top of a hill or on the ocean, or whether it's just partially exposed, so they're like whatever, living in a subdivision with whatever half-acre lots, and it's like, but it's not on the side of a hill. And then an unexposed house, which would be subdivision like row housing or whatever else, where the house beside you is protecting you from the wind or any huge amount of exposure. So, but it makes a difference. Like on a brand new house, we're looking at it, it goes from, an unexposed house is a half times the volume of the house, like 0.5, where an exposed house would be a 1 factor. So if the volume of your house was 20,000 cubic feet, it'll be 10,000 BTUs heat loss compared to 20,000 if it was sitting on top, the same house was sitting on top of a mountain. It does make a difference. When the wind blows by, which will be one of the things I'll go over, but basically when the wind blows by, you lose the surface tension of the air that's on the outside of the house that's helping you keep the heat out of the house. Just with those guys that live in windy environments will know that that's just their house is always a little cooler when it's windy out. So the cooling ones are the same. The difference is now we have to take into effect a whole bunch of other things, which I don't really want to go over because it gets complicated, but the one thing we have to go over is the fact that it's west, east, north, and south do make a huge difference. So, and then if it's solid like a wall or whatever else, it's not as critical, but because the sun doesn't shine through the wall. But windows for sure. Okay, Okay, so these are the sheets. I'm not going to go over the sheet. These are the sheets if we did it longhand that you could figure out that we teach the contractors how to fill out. So we do the north side, the west side, the east side, if they're depending on how many exposed walls they have, and then we add them all up square footage, add the windows and the doors and the ceiling and the floors and everything else, and do it longhand. Tekka does have a program that does this, so most guys take the class, learn how to do it, and then they spend the $150 and buy the heat loss program and just enter the stuff in the heat loss program, and all the math is done for them, so they don't have to do it longhand anymore. Okay, so that's that done. I don't need that one anymore. So I'm sure David went over this, but I left a slide in there so you guys could see it, to make sure that as much as possible you try to use tapered fittings. And this is we go over it because this is a duct design class as well, so to make sure that you try to use tapered fittings. It's the same as anything else. If you need it to roll or flow, the easier that it can flow, the less restriction you have, and the less energy it'll take to run, the quieter it'll be, like all those, like lots of things. So it's better if you can. Some guys I've seen, some of the jobs I've seen pictures of, some guys will just oversize the duct a huge amount, like the drop, for example, instead of trying to make fancy fittings, which will help for sure, because there'll be less resistance in that drop. But the more it's tapered, the better it is. Most guys use the tapered fitting on the supply always, because they can buy it from Terry at the wholesaler. The supply, the one on the return side would have to be custom made, and a lot of guys don't want to be bothered, or it costs too much money for them or whatever, so they're trying to keep the cost down so they can make, so they make some of the money the builders are making, all that millions that you guys are making, right? I will just skip over this because we can't read it.
The speaker, you can beat up the audience.
That's right. So basically, what I'm gonna do is I'll basically go over this the duct design and the way we do it. The picture's a little crappy, but basically what we do is we count fittings, and what that does is instead of getting equivalent length, we get a sense of how far away it is from the furnace. So we're able to kind of restrict the fact that that duct that goes all the way upstairs will have less air than the same duct that just goes straight run and goes onto the main floor or into the basement or whatever else. You're going to have less air, so you're going to have to upsize that vent going up there if you want to get the amount of air that you've calculated out in your room by room heat loss. So these forms here are what they go through. So basically what it tells us is on an easy short run, a 4-inch vent will give us 35 CFM, but if we had a 7 fitting run and we have to go all the way to the top floor, we're probably looking at only 25. And it gets, percentage-wise, it's about the same, like a 5 or a 6-inch, which would be more common. A 6-inch is 100 CFM on a short run, which would be a basement or main floor, but we're going down to 75 CFM and once we get to the top floor. So if we need 100 CFM on the top floor, running a 6-inch is great, but it's not going to be 100 CFM if we have to have that many fittings. You're going to have to upsize it or put 2 vents up there instead, or something else. Like something else will have to be done. So those guys that have those contractors that say, oh, I run everything in 6-inch because it's way better, well, that's great, but you're not really distributing it to the way that it should be distributed based on the heat loss per room or whatever else. There's some rooms that only need a 4-inch. Why are we running a 6? There's no reason to run a 6. All you're doing is putting way more air into that room, and then if you only have a certain amount coming out of the furnace, it means you're putting more in that room and you need more in the other room across the hall. So it's better if we size everything properly and have different sizes of the 3. 7 inches on the title. I can tell you in the 10 years I've been on my own, since I started my own business, I've never run a 7-inch run. Just because they're too expensive. We just put more 5s in, or more 6s, or a 4, or whatever we need to do. The grill sizes will always be the same. So it's not like the homeowner is going to see anything different once you guys board everything or do whatever else, but it will cover it. So the other thing that's on this list that I wanted to go over is if you guys are putting just a gas furnace in and an air conditioner, you would use a different chart than a different set of amount of volume. So we would use what they call the 0.3 chart, which is the percent, the static pressure in the duct is a little higher, so we can run it a little faster to get it where we have to go, because the furnaces don't require the flow through them, and we have more range of flow. But if we get to a heat pump, there's sometimes, depending on the manufacturer, a little more, the range is a little less, so we oversize the ductwork a little bit to keep the noise down and to make sure the flow across the coil is well and good enough that it doesn't overheat the compressor and then cause longevity problems or efficiency problems and stuff like that, because we don't want it to overheat. So, because a heat pump will run at 100, 105 degrees Fahrenheit, whereas a furnace can run at 140, no problem. And oil, if you guys, whatever, those guys that are still putting oil, I don't know, can run even hotter, 160, 170. So you have a little more range with the furnace, so we just got to make sure of that. And then when the guy asks you that he wants a bigger wall to put a return area in, it's because the grill size doesn't dictate what amount of air is going to go through it. It's really how much of the plate in the wall is cut out. A 2x4 wall will only allow so much air through it because it's really only 3.5, and then by the time you have the cut marks and go through the joist space and everything else. So when they ask you for a little bit wider wall and it's possible, give it to them. It'll make a difference for the homeowner in the long run to have a little bit more without having to put more return air somewhere else in the house. So that's what the other chart on the other side is. It's just sizing the return air drops between the in the sizing. Like we gain in a 2x4 to 2x6 wall on a 14-inch wide grill, we gain almost 60 CFM just in a 14-inch wide grill. So just imagine what would happen if you start getting into the bigger ones. Like the 30-inch one, we gain like 160 CFM, which is a lot. It could be another grill somewhere in the house that you don't have to pay for, don't have to look at, just because we made the wall to a 2x6 wall instead of a 2x4 wall. And sometimes the plumbers might like you to give them more room anyway sometimes. to run the bigger vents. So there's the charts. I'm not going to really go over each individual one, but basically, if you needed 2,000 CFM, you got to run. If you're in a basic up and down house, you're going to be running like a 28 by 10 main duct. If it was on one side of the house and you ran the whole air through one side, which I know you guys never do. You give them huge mechanical rooms right smack in the middle of the house to run all their ductwork for, because the homeowner loves that. So, okay, so if you guys want to flip over the crappy or whatever sheets you guys have, and I'll go over how to do this so you guys can kind of understand what we go through a little bit. So I knew I was getting late in the day, so I made sure I put some amount of actual manual labor in it so you guys would stay awake while I was going over everything. So I've taught enough times to know the afternoon's the worst time for me to be trying to go through stuff. So, okay, so basically we look at this. So a standard wall, we'll use the example here because it'll just be easier. But I want you guys to understand it. Because you guys can't read it, I want you to write it out. So if we wanted to calculate an outside wall, which is kind of what's been happening with the new code, they've been telling you get equivalent value of R value as opposed to just putting an R20 bat in a wall. So you're actually getting more than R20 in a true wall based on depending on what the outside siding is and what the inside treatments are and stuff like that. You get a little better. This is the same kind of idea. So why is it so foggy? Yeah.
In your practical experience, are you telling us before that the quality of installation of a bat definitely makes a difference in the heat loss of the building? Was that something I took out of context?
The quality of no, just
how the bat is installed or how
it's installed for sure.
You've actually seen that happen?
I've seen pictures of people's houses where it shows where the bat's missing by an inch or two. Like the heat, take a heat image of a guy's house, and you can tell where they screwed up the bats. We didn't know at the time, but they were complaining they were cold, and we were able to figure out that they put the bats in only in one room. So maybe the apprentice insulator did that room or something else like that. But I guess they didn't. They screwed up the bats in that one room because one room was freezing cold, and they were blaming me. So we took some pictures of and then what ended up happening was a big chunk of the room was missing, not like the whole wall, but there was like lines of warm coming through the wall that you could see, not the stud, not just that stud line. If you guys have ever seen those pictures, when they take a picture of your house, if it's really concentrated, you can kind of see where the stud line is because it doesn't stop the conduction of the heat as much as a bat does, but it's still not smoking hot. Well, we saw a situation where like half the room was missing, like it was just chunk. I don't know what happened. They fixed it, and the complaint went away, but they had to pull the drywall off to fix it. So basically, what we're doing is we get to add a bunch of stuff. So the first page I showed you guys is all the individual items, which guys should be able to get. This is the per square foot per degree stuff that we're discussing. So you could figure out what the R value is and go from there. Whoops. But basically what we're going to do is, so we have outside air film. We're allowed to add 0.17. And in this case, it's a brick house, which is fine. So we have a 4-inch brick. So we're going to do 4 times 0.2 per inch, which adds another 0.8. And then we have the 1/2-inch plywood on the side of the house, which is at a 1/2 inch, and it's 1.25 per inch, so it's 0.63. And then we have, in this case, it's a 2x4 wall, so it's only R12. But so we have 3 times 4 per inch, which is 12. And then we have drywall, which is 0.45, and then we have the inside air film, which is 0.68. So basically what we do with this information now is now we go through and then we do by the temperature, and then it gives us the calculation to put into the factor per square foot per degree Fahrenheit. So we got to divide by the temperature difference. So our base temperature that we teach at TECA is 72 degrees, and we count on a 55 degree temperature rise. Okay? So that 55 degrees is that 0 point that I was talking about, where we have to either put a multiplier to go warmer or a multiplier to go colder, depending on where you are in the province. So I need to get to that 0 point to get this factor, right? So if we do 55 divided by 14.73, we get 3.73, which is saying that 2x4 wall, because of the brick and because of everything else, is better than what the 2x4 wall by itself would have been. It's actually better. It's actually a little bit worse than a 2x6 wall, but it's better than a 2x4 wall, which is where you guys are getting into. This has been around. We've been teaching this for a long time, and now it's into code, allowing you guys to kind of use that information to get your equivalent R values on your walls on the outside, which was never available to you before. You just have to build a 2x6 wall depending on where you lived, or a 2x4 wall depending on where you lived, for minimum code requirement. So like I said before, so we get the heat loss, so we have what that factor is, we times it by the square footage that we have, and then we get the BTU loss for that area. So in this example they give us, so we figured out what the heat transfer multiplier was, 3.73, and the area they give us is 360 square feet, which is fine. So our heat loss for that area is 1,343 BTUs per hour. And then I'll get to another slide and I'll show you. I just wanted you guys to have a number so we can compare where we're going to be in the province. We're not going to do a whole house. We don't have time to, so I just wanted you to kind of understand the... Oops. Where did it go? It disappeared. So... So what we do is now is we have that information of 1,343, and then the example they give you there is Prince George, so we'll just use the example. And there's a chart for this, but that's what I was trying to find and I can't find it, so it's in my computer, but it's not on the stick. So for Prince George, we're going to multiply it by 1.87 to get the actual heat loss of that wall in that house. So that wall in that house in Prince George is 2,511 BTUs per hour. Just so you guys understand, Cloverdale is 0. Like you don't multiply, it's a number 1. So you don't multiply against anything in Cloverdale. So the heat loss in Cloverdale will be 1,343, and the heat loss in Prince George would be 2,511. Does everybody kind of understand? So for those guys that live in different climates, you can still do the math. Like we could get to the point of the whole house and then just multiply it by that factor, and we'll get the heat loss difference for the two houses. Exactly the same house built in 2 different climates. There's other heat loss programs out there that you have to do it in that climate, and then if you want to do another climate, you pretty much start all over again and then you do it again afterwards. This has just made it very easy for us to teach the whole province as a whole, so guys can come like you guys have here and come into one class. We can teach the class the same way, and then everybody can do the math and do the calculation. So is there any questions, or does that make sense to everybody? Yeah.
Question one might ask is the new 936 is talking about effective insulation values, where you factor out the 2x4s and the bridge
Yeah.
they provide. I didn't catch whether that's built in.
That's what this would be. This would be the effective, what we just did on this 2x4 wall. Because if we use the chart that I had over there, if we use this chart that we use, heat loss. If we use this one, a 2x4 wall above grade has a factor of 4. Well, it's fine when you only have a little wall, but when you're doing a 3,000 square foot house, it'll add up pretty fast. Even if you can drop it down the 27.27, that one drops it down. And that's just a brick wall. Just imagine if you actually had something that was a little more substantial, or if you wanted to add rigid on the outside of the house or do something else to try to get a little more R value for the customer, how much of a difference it would make compounding everything, adding it all up. So, because I know everybody's doing lots of different things with new technologies and stuff like that to get higher R values or a tighter house and stuff. So we've got to make sure we take that stuff into account. But this just gives you the ability to be able to figure it out. So is there any other questions? No? So if we look at this sheet, basically we always have inside and outside air film. This is where if you have a lot of wind, you're going to lose that outside air film. It's going to be gone because it's blowing away. That's where we start to get the infiltration factor calculation in there, where we start overstepping the like adding more heat loss to the building, because we're not keeping that. Because the brick's not going to do anything. It's just going to sit there, do whatever its R value is what it is. As long as the house is sealed with vapor barrier properly, you're not going to get wind blowing through the windows or through the walls or whatever else like you would on an old 1930s house or whatever. And then there's different kinds of foam boards you guys can use, and I know you guys have sat through enough things as far as different kinds of insulation you can put in walls and all that other stuff like that. But it's the same for the siding, the floor, the wood, the roof. If you have cement walls, like I'm sure there's some guys in here that have built cement wall houses and stuff they do have R value. It's not like they don't have any. So you got to take that into consideration when it's not a standard house. These are all the things that at the end of the day, the person doing your heating system should understand and know to make sure that he can give you the proper heating system, so that no different than when Terry was talking about oversizing the bath fans or oversizing the principal fan, it's the same issue. We don't want to be putting in 100,000 BTU furnace in every single house made. That doesn't make any sense. Even though they're on sale because they bought too many of them, and he's going to give you a deal of a few $100 off or whatever it is. You want to put the right size furnace in, or the right size heat pump or air conditioner or whatever you guys are doing for the forced air side, to make sure that you guys have enough heating and enough cooling in the house. We don't want to have way too much, but we want to have a little bit of a cushion, and we don't want to have too little because the customers, your customers, which are our customers, we don't want them to be unhappy. The big thing with TECA and the way we teach this is to make sure that the main principal thing of us, because at this point we've already taken care of the code requirements for fresh air and all those other things like that. At this point we're making sure that the customer, the end user, is comfortable, happy, safe, and everything else like that. Like they're not going to be cold, they're not going to be too hot, to an extent of, for some of you guys, depending on where you live, maybe too hot here. You could live in a house here without air conditioning and probably be uncomfortable for certain days. But you're not going to live in a house in Soyuz and be comfortable without air conditioning, possibly, depending on where you were and if you got enough outside wind or something like that. You're going to be wanting, the percentage of houses that would have air conditioning compared to here would be a big difference. So we want to make sure that we take care of the customer for what they need based on the environment they're in and which climate they live in. So here's the quick heat loss calculation sheet that I'll explain to you, and it's on the next page. This is just the explanation. So there's two ways to do the heat loss. The one way was the way I just showed you, basically, is make your own form, use the factor, measure the outside walls, measure the windows, measure the ceiling, measure the floor, do that math, get an infiltration factor, and you're done. So you have about 6 lines on an Excel spreadsheet, and you're complete. And if I can get it done quick enough, I have one in my computer, but it's not on here, and I can show it to you. But basically, quick little line multiplication. You just put your factor in, you put your square footage of each thing in, get a total on the bottom, and you guys will have a rough calculation, probably even with the limited experience you guys have doing heat losses, probably 15 minutes to a half hour. It'll take you longer to pull the information off the plan.
What's the factor for windows? What's the factor for window?
Depends on the window. A new low-E double argon window is 19 per square foot. But it depends on the window. If you guys are putting triple glazed, or maybe you guys are putting in higher end double pane windows that maybe have a little bit better R value in them, those are things that you'd have to kind of look at. That's just a generic double pane, low argon, like low E argon window, like a base kind of normal window. Nothing, the insulation value. Yeah, just the value for it. So if you guys are putting in higher end double pane windows, it might be a little bit better. If you're putting in cheap ones, it's just an average, just something to use. It gives you an idea that's close. So, but if you did all that, that's the most accurate way. That's the way I do it when I do a quote. Because I just get I get the wall square footage, the window square footage, the door square footage for that matter, wall, ceiling, floors, add them all in, off a set of plans, it spits out a number at the bottom, and I'm done. And then you're able to get something of some kind of idea. And when I use that number compared to when I do a room by room, it's within 10%. As long as I take the right information off the plan. Like as long as my information is accurate off the plan. But this one's a little quicker and a little bit easier because you don't have to get a lot of those things. But this assumes certain things that you guys have to be careful of, that you're in the assumptions. So this method is the floor area of the structure, calculating heat loss, is based on the average BTU per square foot of a heat loss, relatively consistent when applied with new construction. If the insulation's R20, and it says R14 in climate, but we're not allowed to do that anymore, I don't think. Are we? You guys allowed to build an R12 house still? Or sorry, a 2x4 house? No, yeah, so. And then R40 in the ceiling, double pane windows, and less than 20% glass compared to the wall square footage. So a standard subdivision house. Not one sitting on the side of a hill, solid glass across one wall. It's not, this will not work. So, and it's not bigger than about 4,000 square feet. So, so it'll restrict a lot of things for you, but if you guys are building a lot of those kind of size houses, it gives you a quick kind of thing. So we get the square footage, including the basement, all the ducts are in conditioned space, or you get the, and then the dwelling calculation is all heated areas, and then the third one is the ducts are in conditioned space, but it's used for dwellings, house included. Oh, all heating areas. Yeah, there you go. So, but that's a slab house. So basement, crawl space, and slab. And if we go to this, so we just took the total square footage of the area in. We put the dwelling factor, which is down on the bottom. So we can look down here. Where did my thing go? There it is. So if you look here, it gives you some factors. So are we a exposed house, an unexposed house, or other way around, exposed, partially exposed, or exposed. So all of the ducts are in, including the basement, are in conditioned space. This is the crawl space, this is the slab, and then this is if it's in unconditioned space. So basically, if we're building a basement house and it's in a subdivision, we're using 14 BTUs per square foot. So we put the total square footage up here, we put 14 here. Then if it has a calculation for the crawl space, you can add that in separately. And then we do the base heat loss, so we add them together. We get a total in here. And we multiply the base heat loss by the regional temperature adjustment, which is what I told you. So if it was in Prince George, it's 1.78. So we multiply that by 1.78, and then we get a regional adjustment. And then now we need, if you're going to set the thermostat back, to maintain temperature takes less energy than raising temperature. So if you're going to have a person set it back, if you're putting gas in, you're going to have a setback. You're not going to run it full time all the time. If you have other options, geothermal or heat pump, a lot of people keep it consistent because it doesn't catch up as fast. So we want to make sure we add a 10% kind of buffer on there. So we want to oversize the equipment a little bit to make sure we can catch up in the morning at a reasonable amount of time. And then we add the heat of the outdoor air, which times the regional temperature adjustment, so it's 3,000 BTUs. And then we add it up and we're done. And we have our base heat loss. This one's probably within 15% of the actual room by room. So, and in some cases, depends on how percentage-wise the windows and other things like that, how close they are to the 20% number. So, but it gives you a good kind of quick, because this one, you guys, the square footage of the house, you guys probably already know it's written in the corner of the block, so it's not something you guys have to go look up, depending on who drew the plans. Does that make sense? So something quick and easy for you guys to add up if you wanted to add it up.
That 15%, is it always to one side?
No, it depends on the window count and some other stuff like that and exposure and stuff. So, but it would be close enough that if you put the furnace in that would meet that, you would meet it. I've never seen it be short. It's always on the high side. If that's kind of what your question is. It's always on the high side, if anything. Yeah.
Just curious if it changes to plans, sort of the 24th hour.
Yep.
When the homeowner goes, I want the big 15-foot accordion glass door.
Yep.
Versus what was designed in the plan. Is there some, how do you troubleshoot for that, the size of your equipment?
Well, you would have to, like when you guys did a house, to be honest with you, I was planning on being able to write stuff down, not just stand here and point at a screen. I'll be honest. I've been teaching the class, not speaking about the class. So I was planning on hopefully being able to write stuff down to make it a little easier for you guys to understand what I was doing. But because on a board I could have filled this out and we could have went through the whole sheet and everything else. But so if we did a room by room for a house, so let's just say the house was 5,000 square feet, it doesn't really matter. And the great room in the middle was 1,000 square feet of that 5,000. And then they changed from having 100 square feet of windows to having 300 square feet of window, then you just redo the heat loss for that room. And then hopefully the furnace can be easily changed and it's not already installed and you guys are doing this like, like after the fact. But basically it's not big enough. But my experience has been that if somebody builds a house on the side of a hill with a huge view and puts a pile of windows in there, the main heat source, you can't use one heating control for that whole house. That room will have way too big a heat gain and way too big a heat loss for you to heat the downstairs back bedroom at the same time as that room. One of two things will happen depending on the season. It'll be either too cold way in that corner or it'll be way too hot in that corner when you try to compensate for that. So you usually have to put a zone system in or put some separate system in for that room itself a lot of times. like when you get into those bigger high-end houses. And a lot of times once you go over a certain square footage, you're already looking at the possibility of putting 2 heating systems in anyways, because of the square footage and the limitation on how big a furnace you can buy or how big a heat pump you can buy or whatever else. So you're already looking at that anyway, so the easiest thing to do is to eliminate the room that has the biggest skew off to the side of all the other rooms. Like the whole basement will probably, or the whole lower floor will probably be left roughly the same. The back side of the main floor will probably be not that far off of maybe even the lower floor, but that big room with all those windows and the view and the sun shining in, you're going to have issues with that room constantly. So you might as well just decide from the beginning that, hey, maybe you guys go through the whole thing, go, yeah, we were going to put this furnace in. Maybe that furnace now gets downsized a little bit. Even if the duct is already in, you cap off all those vents and you put another system in for that one room to counteract. Or leave a couple vents in for air movement and just supplement it with something else. Is what I would do if it was me anyways. If it was already installed. If it's not installed, you can do lots of things. But a lot of people, like I don't know how complex you guys get for systems, but a lot of people, no matter how much money they have and how big a house and how fancy a house, they'll put a $100,000 kitchen in before they'll put 2 furnaces or 2 heat pumps in their house. So, yeah, David.
Do you have any cautions regarding zoning systems?
Yeah, there's lots of zoning systems out there. I have one in my house and it works fine, but I didn't try to overcomplicate it. The problem with zoning systems that I've found going to houses that have them, in the 20-something years I've been in the trade, is guys that try to do too small a zone with a big furnace. Is you start getting into bypass problems and you start getting into issues of trying to do like a small or leave a master suite on a huge house. They just don't. Some of the new furnaces are getting better because they're getting full modulation. Some of the geo units and some of the VRF systems are getting better in the fact that you can manipulate it. It'll manipulate the capacity output and you can get it. But in a standard 1 or 2 stage furnace or 1 or 2 stage heat pump, having like a zone of 10% of the load is very hard for the system to control to a point where it's not going to be excessively noisy or really uncomfortable because huge swings. It's where at the end of the day, like it or not. But a lot of systems, a lot of times to put the zone system in and try to serve that one master bedroom that they want, the different temperature of that one room like you discussed, it's not far off cost-wise and to just put another smaller system in. Because a zone system's not cheap to start with. And then once you start getting into like controls and depending on how many dampers you need and stuff like that. And comfort-wise, it'll be way more comfortable to have multiple systems as opposed to just have it turn on and off when it needs to.
Do I understand then that possibly 2 zones would be a good idea, but going 3 or 4 is stupid?
My experience has been about 1/3 is about the lowest I've been going, 1/3 capacity, and even that, you're getting into the potential for a bit of noise. It's comfortable, but you're getting into comfort issues as far as the noise level goes. And most of the people willing to spend the money to put that in would be better served to spend it maybe splitting the house into 2 furnaces and then splitting those 2 into 2 zones or something like that or whatever, if they really want the comfort level. Or, like, I don't know, you guys, this is a forced air class, but we do hydronics too, so it's kind of one of those things. But maybe a combination system would be a more suitable situation for those rooms that don't require any like cooling, is to have maybe a floor system or some other kind of hydronic system in those rooms, just with fresh air coming in them, or some small vent enough for fresh air, and then have forced air in the systems where you know for sure you need air conditioning, and then you can supplement those rooms that might be a little bit cooler because now they have individual control, because radiant's a lot easier to control individually without any issues than forced air would be. So, but there's no perfect system. At the end of the day, I have both in my house. I have hydronic and I have forced air, so it's what everybody likes. Some guys are, and you guys would deal with it too with all the contracts you use, some guys are hydronic only, some guys are forced air only, and I don't know why they can't kind of come together a little more sometimes. Because I think at the end of the day, those customers that have the money will be a lot happier if you actually have I believe if you had a combination of the 2 systems in their house. Like warm floors in the bathrooms, maybe warm floor in the kitchen, in the hallway, in the entranceway, whatever else, and then maybe if you have a room that's a little bit cold in the basement or whatever else, you have a little bit extra heat in that floor. And even if they still have forced air heat in that room, they have a separate thermostat on the wall where they can boost it up a little bit with some floor heat or whatever, so as opposed to anything else. But it's a lot easier to zone because with the variable speed pump, it doesn't really care. It'll scream through the pipe a little bit, but nobody hears that, so nobody complains about the noise screaming through a water pipe. Whereas they're going to scream. If they have 1 vent in that room and there's 2 vents in that master bedroom, they're going to complain a lot more about the noise screaming out of those two vents than they would out of a floor heating the room for them or whatever, and just having fresh air coming in those vents or some amount of heated air. So, but it's all about the money. So, and I know where I am in the pecking order as far as spending money on a house, depending on if they had an uncomfortable house before or not. Because if they haven't had an uncomfortable house, I'm pretty low on the pecking order. So, but that's just my opinion. It's just I think the combination is by far the best system, but it's going to cost a lot more. But with today's technology, you can put hydronic air handlers in and stuff like that, so you can just heat the air with a small boiler, heat the floor, and then if they want air conditioning, you're adding it in anyway, so it doesn't really matter. But you're capable of doing it nowadays. Now, with the amount of technology, it's not just one or two manufacturers now. Now you have a range of manufacturers that can supply air handlers and boilers and on-demand water units and all that other stuff like that to be capable of getting everything you need in the house at a lot more reasonable price than what it would have been even 15 or 20 years ago. Because those things would have been for the only the super rich kind of things, because you would have been spending 20 grand on a heating system. Well, that's what everybody's spending now anyways, so for a decent system anyways, once you kind of count ventilation and everything requirements. Any other questions? Oops. Here, let me just go through this and then we can call it a day. That's everything. Oops, go away. This computer's pissing me off.
Jason, for purposes of Rise videoing this, I'm thinking, how can we get the pages that you referred to in your lecture directly to Rise so we can post this on Tekka's website? Their endeavor is to record this today with minimum editing with Rise putting this up on our website. Would you be able to supply a couple PDFs to Rise saying?
Well, I can. That's no problem. Yeah. So here's the one. There was one thing I missed. That's why I just want to look at the list of what I did.
To help serve the people out of town or the builders here from out of town themselves, we would like to be able to make this information available.
Yeah, for sure. And don't hesitate to get any of them to go on the website, and they can phone David or myself or Terry or any of the other instructors that are around. We're all willing to help. So my rule is David's in a little different perspective because he's a manufacturer, which you guys found out this morning, and then Terry's a wholesaler, so a different perspective, as opposed to me being an actual installing contractor. If for some reason somebody phones me and says, oh, we're Mrs. Smith's house and whatever, if I'm bidding the house, I'll get them to phone David or phone Terry or whatever instead, so that I'm not, whatever, or they don't think I'm steering them in the wrong direction to try to get the job or whatever, right? So, but I'm here to help. One of the reasons, we don't get, a lot of the stuff we do, like the committee stuff and all that other stuff like that, is all volunteer for us. So we want to make sure we're all trying to get the trade to be a little bit better and make sure the contractors are all kind of at a level playing field. So you guys aren't walking up and getting somebody who has a gas ticket and that's all he has. And there's nothing against those guys with gas tickets, because I have one too, but they don't have any other experience. They've worked in the oil patch for the last 15 years and they've been running gas lines this big, and all of a sudden they're going to be doing residential heating systems. It's not what they did, what they've done or where their experience is. It would be like you guys going in, for some of you anyways, and going and building a condo, right? If you guys are residential home builders, you're building houses, you build houses, and you do a good job building houses. Could you build a 20-story condo? Maybe, but maybe not. You'd run into some problems. So we're trying to get the industry to kind of come bring themselves up so that we're not looked upon as being uneducated or have problems like those kind of things. So any questions they have, just get them to phone or go on the website and get the link or talk to the office, and they can easily talk to one of us to try to help us through it. Or hopefully they'll take a class after you talk to them and question them a few times on a couple things that you've learned today, and then go from there. So, but the one thing I wanted to go over basically, because this is the one thing, like Terry has the thing about the makeup air, this is the one thing that is screwed up the most as far as those guys. Because how many guys in this room get heat pumps and gas furnaces put in their house? Any? None? Yeah, so basically, I'll go over it quickly. This is one of those things that I passed over because I don't have a board to write on. But basically, if we count on you living in a certain district, we'll just say that it's whatever 80,000 BTUs. The way this chart kind of works and the way we want to be careful of is you draw a line down from 0, we lose 0 BTUs down here, and we draw at 60, and we draw a line across, and then we draw a line for the capacity of the heat pump across, and where they cross is where the heat pump is. But basically what we want to be careful is, and why I wanted to get this over with, is a heat pump, a standard heat pump, like a North American built heat pump, single stage heat pump, loses capacity when it gets cold outside. So, and some people don't really think about it or do whatever else. They say, well, I'm putting a 3-ton heat pump in, it's 36,000 BTUs, I have 36,000 BTUs. The house only leaks 35,000, I'm good, it'll heat the house, no problem. Yeah, no. So, and they put a gas backup in, or electric backup, it doesn't really matter, but they'll say we'll use gas. So they put a 40,000 BTU gas backup in, which is more than the 36,000, so they'll easily meet the heat loss, and they go through the whole thing. The problem is they've had this, now they set the system up so the heat pump runs, because wherever they live, it's way cheaper to run the heat pump. And then what happens is now that 3-ton heat pump that's 36,000 BTUs at 47 degrees Fahrenheit outside temperature is now only 20,000 BTUs at 17 degrees Fahrenheit, and that's where the design temperature is. So you're 14,000 BTUs or whatever less than what you need. What this chart or what we can do or what they should be doing is they should be figuring out at what temperature that heat pump won't have the capacity to maintain the temperature in the house. And that's what we call the balance point for switchover, where you have to switch over, like to make sure that the house stays at 72 degrees. So just make sure that the guys that you're dealing with understand the fact that there is a magic temperature and they should be putting a system in. And we used to have to put kits in and stuff like that, but now the thermostat and control systems will deal with it for us, so we don't have to do those anymore. But we want to make sure that that temperature is set up so that the heat pump turns off and the gas runs, because the gas and the heat pump cannot run at the same time if the whole system is put in for code anyways. So the other balance point temperature one for guys that are doing this kind of system is to get them to try to do the math calculation for the economic balance point, because what you may find is that the numbers aren't exactly the same. It might actually be a few degrees warmer, where it's better for you to turn to the gas earlier than what this calculation tells you have to turn it over for. So there's a couple of calculations that the guys could be doing for you guys to make sure the end user is getting the best bang for his buck between the two systems economically, and to make sure his house is comfortable. So
don't forget that economic balance point. You guys have got a gas furnace now and a heat pump, and you bought it in good faith 5 years ago when there wasn't second tier power. The answer is a whole different ballgame today.
Yes.
With 12, 13 cent second tier power.
Yeah, so just pay attention to it and figure it out and do the math. Yep.
Just got a question for the gas and propane.
Yep.
Even if there is no natural gas and there's only propane.
Okay.
Are those calculations sort of synonymous?
For which one? You're talking about for this for a heat pump? Like, where do you live?
Just sort of with the, say, propane fired furnace, for example. Is
I know,
it
where are you?
similar than to a natural gas fired furnace?
Well, the cost to run it's way more money.
That's what I thought.
Yeah.
Yeah.
Right now, my understanding is, the last time I did math, if out of all the new systems, propane is the most expensive way to heat your house. It's more expensive than electric.
In our office, we keep a record of all the fuel costs updated every year. Propane, wood chips, coal, cordwood, natural gas, propane, electricity, and there's about 12 different choices. And propane is the worst of the bunch. Next is oil, and natural gas slaughters them all other than coal. But I haven't convinced anyone the last 20 years to use coal to heat their house. Wood chips are right up there with oil. Wood chip, what do they call it? Pellets?
Pellets, yeah.
Are still a loser.
So, is there any other questions? Okay, so for those of the guys that want me to send them some of this stuff, just contact Tekka or whatever else, and we'll get it taken care of for you. So I can forward it, and I'll probably just get it put on the thing, and you guys should have access to that anyway. So access to the video, which will have I'll try to clean this up a little bit more for the ones that weren't readable, and then get it put on for you guys to.
If you guys have anything to say to make this better next year, we would offer to do this next year. If you think this would be an advantage, never hesitate to send your comments to Catherine or send them directly to the CHBABC office. But we'd love your feedback, for good or for bad, what we can do to help you, because we see you as customers. Our industry sees you as customers of our services. We want to help you with anything we can share with you.
And that's Catherine right there.
And if you haven't signed the.
Oh, you're gonna sign in, yeah, you have to sign in to get credit.
Yeah, you have HBO development CP credits for attending today, and also our ventilation course classes. If they are HBO approved for CP license officers. And if you're interested in becoming a technical member, we have membership signage. You can get a membership application form, and we'll extend that membership till the end of next year. We have a lot of homeowners that we call our office, so they're looking for quality installations.
What does membership for a builder cost, Catherine?
Well, we don't, for a contractor, it's about $240 all in with taxes. And that is, the company becomes a member, and anybody in your company can take our courses at the member, which is about $75 to $100 per person discount for each course.
So how much would we charge a builder like Mark Godwin? Would he go in at the contractor rate?
Yeah.
And other than that, you guys are good. You guys can go home and or drink beer, go back to sleep again.
Thank you.